Today's lesson we're going to talk about the imaginary number I. Okay, just to kind of start us off, I is not a real number, it is imaginary. Da, 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 da. The thing about it is, we were talking about simplifying radicals. If we end up with a negative number inside the radical, okay, it's going to be imaginary. You cannot take a square root of a negative number. Right here I wrote down I equals square root of -1. Okay, try to memorize these four little pieces of information. I squared, that's going to equal -1. Because if we go out to the side here, square root of -1 times the square root of -1, okay, it kind of is what it is, -1. Okay, so kind of put this in your brain. I to the third power. Okay, what does that equal? Well, that equals -I. Yeah, I can't make an I. How is that? If you take the square root of -1 times the square root of -1, since we're doing I to the third power, it's going to be times another square root to the -1. What happens is, these two things we already done, square root of -1 times square root of -1, well, that equals, I'm just erasing and my stylus isn't working right, that equals -1. Well, what does the square root of -1 equal? This guy right here. Well, that equals I. So I can replace that with the I. Well, what's -1 times I? -1I, or just -I. Now this last one I want you to memorize, I to the fourth or I to the 0 power. Okay, what does that equal? That equals 1. Okay, so I can highlight the ones I want you to memorize. These little conversions. This is +1. Okay. Why is that? Why is I to the fourth or I to the 0 equal to 1? Well, guys, I to the 0 power, that goes back to anything to the 0 power. Well, if that was 3 to the 0 power, well, anything to the 0 power, if that was x to the 0 power, that's all going to equal 1. So anything to the 0 power equals 1 anyway. But if you got I to the fourth power, let's examine this. You got square root of -1 times square root of -1 times the square root of -1 times the square root of -1. So we got 4 of those there. Well, we know that 2 of them equal -1 times these 2 equal -1. Well, what's -1 times -1 equal? 1. Oh, excuse me. All right, let's look at a couple examples, or probably just one example. I'm going to keep this clip pretty short. Let's say we have 7i plus 3i times 6 minus 2i. Okay? Well, if you're working with imaginary numbers, okay, I is basically a variable. Okay, you want to combine like terms. You're just simplifying expressions. First off, something that you learned in Algebra 1, distributive property. Let's go ahead and distribute that. Be careful with your signs. That is positive 3i. Keep that in mind, because that's going to play a big part here in a minute. You got positive 3i times 6. 3 times 6 is 18. So you got positive 18i. Don't forget I. And right here we have positive 3 times -2i. Well, what's 3 times 2? 6. Positive times a negative is a negative. What's I times I? I to the second power. Now bring down 7i. Now I could combine these two terms here. Remember, like terms have the same variable, same exponent. That'd be 25i. But here's a little twist in the problem. We got an I squared. Now if you go back and recall I squared, well, what does I squared equal? -1. So what I'm going to do is plug and chug -1 in for I squared. Now I can work this out. That's just going to remain to be 25i. Now, careful with your signs. I got -6 times -1. Negative times a negative is positive. 6 times 1 is 6. Okay? One more example. Let's say we had to simplify I real quick. Alright, this won't take very long, guys. Let's take I to the 7th power, I to the 23rd power, and I to the 36th power. Now, we know what I to the first is, or I. We know what I squared is. We know what I to the third. We know I to the fourth. Okay? Now, I'm going to use that and apply it to simplify these three problems. Now, here's all you got to do. Try to find a remainder. Okay, when you're dividing, you usually get a remainder if a number don't go in there perfectly. Especially if you use a calculator. You know, it's pretty simple. Let's take this exponent 7 on this first problem. 7, I want to divide it by 4. Okay? And you'll probably get some kind of decimal that ends with this. 0.75. It's probably 1.75 when you divide it, but that 0.75. Well, what is, well, let me go back a little bit. How many quarters equal 75 cents? 3. So I to the 7th, you can reduce this down. I'm going to separate this out to I to the 3rd. Well, what do we know about I to the 3rd? I to the 3rd equals -I. So there is my answer, -I. So it's all about the decimal. I'm going to change this one here real quick. Let's change that 23 to a 21. Let's go ahead and do the same thing. We're going to take this second problem here. 21 divided by 4. Okay, I don't care about the number in front of the decimal. It's the number behind the decimal. That number behind the decimal is 0.25. Well, how many quarters equal 25 cents? 1. I got I to the first. Well, what does that simplify to be? Square root of -1. So I can write square root of -1. Okay? Last but not least, I to the 36th power. We can get really crazy with these. But just ask yourself after you divide, how many quarters equal that amount? Your decimal is either going to be 0.25, it might be 0.5, I'm going to write that out to the side, or 0.75, and you may not even end up with a decimal. My stylus is acting up, I'm sorry. Okay. So you may end up with one of these 3 decimals here, or you may not even end up with a decimal at all. If we take 36, divide that by 4, we get 9. Okay, I don't have a decimal. Well, that's no remainder. So I'm going to write I to the 0 power. Well, what's anything to the 0 power equal? 1. Alright, gang, that's about all I got. I'll see you in class.